All right, we're ready to get started on a presentation that Nielsen's going to make. It's my pleasure to introduce Darrell Pratt. I just found out that he's the architect of architects. Well, and he's going to tell us all about Nielsen's Global Buy Platform. Darrell?
All right, thank you very much. First off, can everybody hear me? Somewhat? Okay. What I always ask at these things, the first thing is, first off, how many people out there have heard of Nielsen? Just a kind of a raise of the hands. Hey! How many people think it's just TV ratings? Okay. So this will be enlightening to some people, I guess, that we're not just TV ratings. We're not just net metrics, if you know that piece, or some of the online ad tracking things through our Twitter and Facebook partnerships. So let me run through the few slides here that I always joke that legal got in my deck. So mission statement of Nielsen is really to help our clients have the most complete understanding of consumers worldwide. So we always talk sort of a 360 view of our consumers. We want to know, everything about them to be able to basically sell them more stuff, right? Nielsen is really split into two divisions. So most of you kind of raised your hand that you know TV ratings, which is the watch side of Nielsen. The other half that I'm really involved in is the buy side of Nielsen. So you'll kind of see it across our little ecosystem here. So online, sort of what people know about is our partnerships with Hulu, Yahoo, Google. Shopping-wise is really where I'm involved at. So partnerships with Amazon, Walmart. Those are just some of the bigger ones, and we'll get to a little bit more of the numbers later. Social, obviously, the big players there. Cross into mobile, so actual tracking of mobile devices, usage there. Into television, obviously, that's the main one people know. That you've heard of Nielsen families. These are the families that don't divulge who they are, or you bug them wanting Star Trek left on their TV or something like that. Into print as well, and radio, and even as sort of esoteric things as billboards as well. So we actually track your viewing of billboards, which is rather odd, but we do. So on the buy side of the business at Nielsen, we have a platform that we expose to our clients. It's called Nielsen Answers on Demand. So this is a sort of an ad hoc reporting system that our clients can log into. They have, depending on the contract we have with them, they have a certain period of data that we've collected that they can run ad hoc reports off of. So they can run anything as simple as how is this one product trending in sales versus a year ago in this one market, or how is this full set of products comparing to another product? What's the product share in a certain category? So it's those sorts of things is what we give them. So it's a dynamic on-the-fly processing engine, meaning you're not, it's not the old days. You're not submitting something and getting some report sent to you the next day. So this is all online, all dynamic system. On-demand products, markets, periods, buyers groups. So you can also sort of generate these things yourself. So you can come up with groups of products, come up with groups of markets that's your own definition of a market, and segmentation beyond that as well. A lot of security in there, so a lot of user role-based reporting. And so really too much security, but sort of, who are the team leads? How can you share reports? How can you publish reports out to different divisions? Things like that. Speed to insights, really our old mission statement before the other one was that we're providing you with the insight into the data. So we don't just give them the data and say, well, here's all this great data and you go figure it out. Certainly some clients won't want that. They just want a huge dump of data and want to do their own thing. We also try to guide them through roadmaps that says that, okay, well, you've run this one report. What does that mean? What does that really, what can you answer today based on that data that we gave them? And then integration. So we integrate multiple data sources into all this. I'll show that in a second. So here's our, I think our last little slide here. Our promise. So it's consumer foresight for faster, smarter, more confident decisions to drive growth. So that is really what our partners and clients are looking for, is to understand, what does the market look like? How are the products performing in the market? And answers questions of how do I price a product? What new product makes sense in this market? Which market should I focus on? So that's what we're answering for them. So consumer data is really what we look at. We have really sort of three sets of data here that we deal with. We have scan, which is point of sales data from, I have thousands of retailers in there, but it's really, in the US, I've kind of heard somewhat that it's pretty much all of them. So we get data from almost every retailer, and it's either daily, weekly, monthly, and we get sort of disaggregated anonymous data, meaning we don't know who it was, we don't know if it was in a basket together, we just know that at the end of some day, they sold 20 of these things, and this was the unit price, and this was if it was on sale or not. So that is obviously billions of records per week. Panel is sort of like the Nielsen family for television, but with consumer product goods. So we have Nielsen households that have scanners, and when they get home and buy something, they scan the UPC of something. It gathers all that data up and sends it to us in a feed. The trivia question, one of the guys at work told me, well, what's the most expensive thing that's ever been scanned in by a Nielsen family? And it was a coffin from Costco. I didn't know they sold those, but I'm not sure why they would think to scan that in either. So that the panel gets us to the point where we know trip and demographic data, obviously, because we know who the family is, we know, that they made a certain trip, but we still don't really know basket data at that point. So that is millions of records a week there. So loyalty data is Safeway's out here. So your Safeway card, your Jewel Osco if you're from the Midwest. So it's that card that you always scan to get the 10 cents off something. Those retailers will give us that data as well. And in that, we have a lot more information, obviously. So we have basket level transaction data at that point, and some demographic data. They don't give us everything because they don't, obviously they don't want to give all that information to us. So that's hundreds of millions of items weekly. So that's really our sources of those data, and it's how do we combine all that, and how do we give someone sort of a logical view into that data, into that, how does it make sense? What does it tell them? So client-wise, you might know who some of our clients are based on what I'm saying, but obviously manufacturers, Kraft, P&G, others as well. What they're doing is really measuring product success, right? So they want to know, how is my product share faring in some market, like I said. So I've introduced something, or I've done an ad on some piece, like a shampoo. How is that in the category now? How does that do in that category? And understand consumer behaviors. What are they, if they buy this product, are they likely to buy this other product? Is it in the basket with that product? How are the stores? Is there, are you leaking sales of some product at one store because they might not have it there, or it's cheaper at some other store, and a loyal customer leaves that store to another one to buy that one product, something along those lines. So identifying new product opportunities, just extending a product line. This happens weekly, really. Down to product pricing, the whole gamut there. So retailers generally, we're obviously working with to get that data. So these are the people giving us the point of sale data. Big clients there you see, Safeway, Tesco, Walmart. And we more or less swap them information for their data. It's kind of generally how it works. So they want to see the same thing, is understand the consumer buying behavior, look at their store performance in a market, which is what they don't have, right? So they have all their data, but they don't have their competitors' sort of data as well, which we can show. And then product pricing as well. So, they can see that if they had an end cap display on some product in some market, how did that affect these sales versus these other stores in the same market that didn't have the end cap display? So it's things like that. So it's to understand how to better market products in their retail locations. So the Answers on Demand application, we just, last Friday, I think, pushed this application into sort of a soft launch production. So Couchbase is live at Nielsen. And soft, we have sort of, it's out on our portal, and you can kind of get to it, and we're kind of letting customers slowly but surely come in to see the new system. Because we've replaced everything they know with completely new applications. So we're taking our time with them. So this is our report builder. So this you'll kind of notice on the left side, there's sort of the report object up on the top left. So it's, it's what can I put into a report? Typical, tables, the different sort of visualizations, page containers. At the bottom is really the dimensional data that's describing, it's really sort of the where on the query, right? So it's saying, I have in this one some facts, so dollar sales, dollar versus percent change, year ago, dollar, that sort of thing. And then I have in my periods a certain maybe years that I'm selecting on, usually it'd be weeks or quarters, things like that. So that's really the data, and I'm allowing the user to drag all that out onto a palette, assign out how these things are getting filtered, what data shows up where, which things are in which columns, and we put almost no guardrails on that for the user. We kind of say that we want them to be able to do anything, but we're not going to help them out too much if they fail at doing anything as well. You got to do something like that, right? So this is the first one was builder, the second one is player. So this is a report that's actually run now, and you can see the users can basically build out a report that has, this has a table on the top left. It's what we call sort of a nested data table that's tied to a line and bar chart, and then other charts down at the bottom. And all these things can be tied together so they can, they can slice with an OLAP slicer at one point that all the data is connected down beneath it as well. So they get the sort of view and any sort of data they want to look at, really. As you can see, it could be effectively be more than one logical query in the back end as well, because they could do completely different data on different tables. It's the sort of report you would take to the, if I worked at Kraft or somewhere, I might take to my product or category lead, the category VP, to show them, okay, in the Chicagoland marketplace, this is how we're doing. This is how we did last week. Another little picture of report player. I just put up a lot of screenshots because I think it's a pretty cool application. If you want to see it sometime, I have a little movie. I can show that later in the day or something like that. This is all, we'll cover the details in a second, but it's new application, new technology, and we're pretty excited about it. And one other last little thing to show you kind of what some of the data looks like that I keep talking about. In this field, so I keep referring to dimensional data. So you really have what we consider in a way as market, product, period, and the one that's not there is fact. So that's really our dimensions, and that's the kind of data we keep, right? So we have dimensions beyond that are derived dimensions on those base dimensions. But when we talk about data, that's our data, right? So we have, this is a screen showing the metadata that a user is going in and making selections. They're effectively going to filter out a report that's going to run, so they're making metadata selections. So this is what we always term metadata on top of our dimensional data underneath, or our trend data underneath the covers is what that is. So the features of this, so it's a single front-end web application, and it interfaces to multiple disparate back-end data sources. So through that one interface, the user, depending on how they've dealt with us or how their contract is signed, they have access to the loyalty data, or they have access to that scan data, they have access to panel data, they have access to survey data. They can see all of it on one screen or just parts of it on one screen. But it makes no difference to the front end where that's coming from. So advanced BI capabilities, user expressions. And the joke we make is that effectively when product management came to us, it was pretty much make it do anything Excel can do. So we're close, and it's basically what it is. So the user expressions, so I can say I want this column to be divided by 10, and whatever, multiplied by this other column, and I can put that in the report and it'll figure that all out for them. Conditional formatting, obviously I want these rows highlighted if the cells are under $1,000 or something like that. Smart text is our term for if I have a chart, I might want to drag a piece of text above the chart that changes the verbiage of it based on the data underneath. So your cells are up, cells are down, this is not good, this is bad, whatever. Smart linking of report objects as well. So the user can define a report that links from one report to another report and is driving context between the two as well. So we allow them to do that too. So like I said, there's very few limits of what that user can do, and which is good for them and bad for us for the most part. So we expect most reports to run under 2 minutes, basically, with almost no limits on what the user can do, which is a hard thing to promise, but that's generally what we have to promise. So application specifics. My clicker's working. So sort of very, very high level overview. So at the top layer, we have a presentation layer that is a very lightweight HTML5 based presentation layer. So I showed you kind of the report builder, report player. The data selector was that ugly screen with all the data selections and the trees on the left side. and a portfolio manager where think of it as like your file manager. So this is where I'm saving reports. This is where they're all folded out into roadmap selections, that sort of thing. Our middle tier is made up of Java. And the way things work these days with Couchbase and the lightweight front ends and JSON, this is, in my time, this used to be the big one. You used to have thousands. You would come up with like 600,000 lines of code in this layer for something fairly small. This, in our system, is almost nothing. Like we have, at one point when we first started with one of the apps, I think we had 5 Java classes in the application. So, I mean, of course, the JavaScript is bigger at this point because it's doing quite a bit more, but it's still MVC and clean. So in that layer, it's basically Spring, really for the configuration aspects of it. Some caching sort of wrappers and what we consider to be an L1 cache where we need it in the JVM. Beyond that is Couchbase, obviously, or I wouldn't be here. So there's Couchbase behind that, and we'll get into the details of what we're doing with Couchbase in a second. And then Oracle and many other databases behind the scenes. And service layer, really that we kind of used as a facade over all of that data, and the process for how that data moves around is through a service layer. So a little bit more defined here. So like I said, the web front end, Java middle tier there, we do have a Couchbase cluster sitting in the middle. We're currently just a 4-node cluster. It will be going up large machines, but we'll double it at the end of this year and keep kind of going from there. And then we are using Elasticsearch kind of off to the side of that cluster as well for full text searching against that metadata. And then at the bottom there, TIBCO for, it's effectively our ESB. So it's what we're using mainly for messaging and some orchestration with BW on AMX. And then much further down, Oracle RAC is really for some of our core metadata and segmentation. And at the very, very bottom of the stack are Netezza machines that they are what they are. They're very expensive, but if you have 10 queries to run at once, they're very fast at doing that. So the UI, and I was excited to see the Sencha guy here today, and I think there's some quotes from another Sencha guy. So these technologies fit real well together, actually. The UI is built on Sencha EXT.js. We use AM charts that you saw there for charting, and we use D3 for some of the edge cases. So the one edge case that product always wants is Venn charts, Venn diagrams. And I still don't understand what you get from a Venn diagram, but they want it. Because they never want the actual percentage overlap to be correct either. They just want an overlap that shows, so we can do that. So we use D3 for that, for the Venn diagrams. Like I said, middle tier, Spring. And what we're really doing there is exposing our JSON REST endpoints for things that aren't in Couch. So everything above in that stack can treat the rest of the world as JSON, which is, I think it's a term we keep throwing around here, right? JSON anywhere. We use, since TIBCO is TIBCO, we have XML to JSON conversion happening there, basically dynamically. And then back in the back end, like I said, we have service-oriented architecture with TIBCO AMX 3.2. Couchbase, we're currently on 2.1.1, I believe, in production. And like I said, we'll get into details, but it's effectively storage, caching, and search for us. And then our build chain looks probably familiar to any Java shops, which is Hudson, Artifactory, Gradle. We are a large amount of JavaScript or Jasmine for test cases or for unit test, and JSDuck when the developers actually put documentation in the code. So I think is that you'll probably hear from a lot of people here is that we started, we were looking for a caching solution. And I think you'll probably hear in a lot of the case studies, it's always cache this, cache that. We were one of the people as well that had, we had EH cache, we had Terracotta, we had, you name it, we had it. Even in the one application, we had that many different caching solutions. So we started really looking around. We need one that makes sense that's going to work for us. So what our needs were, scalability. Obviously makes sense. If you're trying to, put everything into one piece, it needs to be scalable. You need to be able to grow it easily when you need to. Speed, and speed's not quite right here without explaining what I mean by that. So most of those caches I just mentioned really run within the JVM, which is, it's good in a way because it's like a level 1 cache. You're right there in the JVM if you're Java where you need it. But at the same time, the things you run into really quick with most caching solutions that are that way as garbage collection will eventually kill you because you're keeping a ton of stuff in memory, and eventually your GC will come around and hurt your application. So we really wanted just to boot it out of the JVM process completely. Let's get it out, put it on another machine. And then our big one at Nielsen is support. So this is why you guys are great, is that you probably run into this a lot of enterprise clients. Open source is really cool and all, but when you put open source into production, any Fortune 500 wants somebody to call if something goes wrong in production, right? So you have to have those support contracts in place. You have to have 24/7 support, which is what we have. And then phrasing it as our wants above those needs really was document storage. So the things that we're doing there are those reports and how users are defining those reports and what metadata looks like. It's not traditional. It's not something you would traditionally want to keep in a database. It has been, but it doesn't make as much sense to do that. The map-reduced views was, as soon as we started kind of seeing it, it definitely went on our want list. And I'll explain that in a second. And then full-text search as well. It's something we wanted to handle sort of in the same system. We didn't want a completely different system to be able to do that. So why NoSQL is probably something everybody has to prove to somebody or ask themselves. Like I said, the relational data model overload was kind of one of our big issues. So it's the complexity of those objects and how much they change causes so much churn. And if you're using, if you're somewhat modern, you're Hibernate or something in Java world, even that, I mean, you're recompiling everything, you're regenerating everything with just little changes to a database. And it's, over time, that just gets to be way too much of a hassle. And then poor performance. I love our DBA that started on it, but he's kind of like a BI DBA, or data warehouse DBA. So our database for somewhat you would think something fairly easy, is 12 tables to define a report, right? How do you put that back together, and how do you get performance out of that? And then we really wanted to get out of the business of all those data transformations, right? Because we're serving up JSON. Why are we breaking it all apart into tables and different columns when it just doesn't make sense to do it? So the flexibility of the data model, like I said, is really near #1 requirement for us. Scalability, probably tied with that #1. And then data sharding and the replication for reliability. So it's hard enough to bring in a new technology at a big company. You have to bring in a new technology that you can say, look, it's reliable as well. This is a fully clustered sort of solution. It's going to work and meet our needs and be up, right, which is a huge thing. And then JSON encoding, which is actually what got us approved by our CTO office. So we proved all the document storage stuff. We proved all the caching, the searching. What eventually was the exception to get Couchbase in-house was that we can store JSON natively, deal with it natively in this system, and have our storage of that data right near our UI in the format it needs to be in. Right? So we're not doing all these transformations. We're not building up Java objects here, then marshaling them out to JSON, then sending them over the wire. We're getting rid of steps there, which is very important. So our usage, like I said, so it's really storage of the native JSON data from the application. So in those reports, any of the reports the users build up and define, they can save those things. And we have individual users who save thousands and thousands of those. Right? So we save all those report data as JSON to Couchbase. The report definition itself, which is a little hard, it's sort of more of an internal thing, but we have a lot of that data as well. It's sort of like, what can you use in a report? What works with what components are there? What is in the system that way? Something we call the request instance, which is really you have the report plus the data that filters that out, obviously. So you have a visual definition of a report and the data that makes that happen when you run it through the player. And then our sort of caching instance of all this is we run our responses back from the bottom of our stack up through Couchbase. And this way we can break them apart and have the UI deal with smaller chunks when it needs them. So dealing with reporting data. So making it responsive, obviously. So we're trying to be as asynchronous as possible in the UI. So Ajax, whatever. Web workers when we can know they're on a modern browser. There's lots of ways we can make the user not think we're doing much of anything, and they're not waiting around for things to happen. we try to get rid of the spin wheel, basically, to never show up. Reporting data gets large, like I said, so Couchbase is really handy there because we use it sort of like a session store, which I think a lot of people are probably doing, is that that one user's very large report object comes back from the bottom of the system, and it could be megabytes in size. We can break that apart into what the components in the UI that might have needed it. So we'll only send back the part we know might be on the screen, or the part they might be actively working with. So we can start chunking that out and making it, we want to get the user from making the selections to the report to one actionable piece of the report as fast as possible. So that's where that sort of breaking it apart comes in handy. And then the asynchronous storage of them there. I think I covered all that. So like I said as well, it's really sort of this moving of the data efficiently. We have, all the way from the back, there's a lot of hops. Database, Netezza, Composite is a data federation tool. TIBCO EMS might be in there for messaging between things. You have TIBCO AMX in there working as an orchestration layer. Then finally, you have a web tier above that. It's probably very similar to what a lot of people have. So Couchbase, we try to typically use now, rather than passing all that stuff all up and down the stack, we're trying to push it into Couchbase really, really early on and just have it basically pass by reference up and down the stack. So Couchbase is very quick. We can do those gets and puts very, very fast. And then each of these tiers just works on it, grabs it, does something, puts it back. And then, like I said, also, we're trying and we're working toward getting that JSON encoding further and further down the stack. So we're trying to get, XML to me is horrible. So we're trying to get very, very far away from that, but trying to push JSON further and further down the stack to make it, like I said, we don't need to be in that business of transforming that data. We do enough ETL in the other half of the business. We don't need to do it on the front end too. And then true persistent storage with in-memory performance of that as well. So one of our big things that happens with us anyway is dimensional data does change, obviously. It's those products, markets, periods, and facts. Those are all described by characteristics. So the easiest way to, if whoever's kind of dealt with this sort of data before, but a bottle of water, how many ounces is it? Does it claim to be organic? Does it claim to be non-GMO? What color is the bottle? All those things define a product. Those change all the time. New products come around. There's new UPCs. Markets come and go. Markets might be bigger or smaller over time. Facts, we come up with new facts all the time. At last count, it was like 50,000 facts in the system. So these things just change, constantly. And error as well. We'll always get something from a retailer, and then a week later they'll say, oh, we didn't mean that. That's all wrong. So, unfortunately, it's in our system that way at that point. So those are, weekly. We really deal with it, but it can be daily changes like that. So those changes create huge waves through the system. And if we were storing it the old way, where we had all that stuff in, which some of the systems still do, where it was maybe a clob in the database in XML, one little change to one characteristic that the user has saved, all the users have saved 50 million saved reports, and you changed one characteristic, you have to go looking at all of them to figure out which one's changed, and you have to update their data, right, if you can. Or at least you have to flag it as being wrong, so they know when they come back to it to see, well, something changed here and I have to deal with that. So we have a large metadata change management process, so where we can catch those differential changes at the inception on really the ingest of it. So, it is that user saved data, saved selections, saved reports, any of that sort of stuff, the selections or the filtering on the report, all those things can and will change. In the segments as well. So, like I said, before it's the storage in clobs. I'm sure everybody's done it before, and it's, it's not very good. There's full table scans. You have to write your own code to go off and do those full table scans to grab it all, parse through it all. And we always joke that we do these changes on the weekends. We keep joking we're going to have to come up with a new day, right? Saturday and Sunday aren't generally enough. We're going to have to come up with something in the middle at some point because there's too much change happening on the older school techniques of doing this. So with Couchbase, it's pretty easy. We just set up the incremental map-reduced views. We can catch on the things we're wanting to catch on, and we have our results basically instantaneously of knowing this characteristic changed, pop, there's all the data, make the changes. We can do the async, gets and sets to fix the data itself. So huge, huge change. So let's see where I'm at here. So looking forward, getting Couchbase more of, and I say first-class data storage application, really at the bottom of our system. So we come through the mainframe acquisition of all this data from the retailers, and that goes through a mainframe, very large analytic process to baseline the data and fill in the holes in the data. I joke that it's like in Jurassic Park where they filled in the DNA with the frog DNA or whatever. So you have to fill in the same sort of stuff with sales data, because it's not all there. It's not all right. Prices are wrong. That stuff has to be done. But get Couchbase all the way down at that level. So make it a first-class citizen when the mainframe data is coming in. So make it right there at that lowest level, not go through the other systems we have. Right now, we still wait on a database build process until Couchbase can come in the picture. So we're trying to get rid of that, make it first class. And move to full storage of that metadata in Couchbase. And we're, data-wise, we have hundreds of categories of different data we're looking at. Each of those has those dimensions on it. Each of those dimensions are large tables with all those characteristics, and then there's millions upon millions of items within that. So it's a large amount of data, but it still makes sense to push all that to Couchbase because it's just quicker dealing with it at that point. And then when we really start thinking about where we want to go is the MapReduce view is to start capturing statistics on the data and start capturing through sort of crowdsourcing what goes together in the data, right? So if a user selects these 5 characteristics, we can say, hey, these 2 also fit with that. You should add that to your report, and it will self-heal over time with the products that are selected. So when we get this data in a better format, we can start doing that. And then, like I said, predictive analytics, that's the new buzzword, I'm sure, here as well, using that collaborative data. So I think I finished with a little bit of time. All right. All right, thank you.